This video is a complete tutorial on authentication with Angular and MongoDB. We're going to look at how we can sign users up and persist their details securely within the database, and then we're going to allow these users to log in. We're going to explore web tokens to allow our users to authenticate ourselves, and then we're also going to look at route guards so we can protect certain routes from our application for only logged in users. At the end, we're also going to look at how we can automatically authenticate users even when they navigate away from the web page. I've left a link to the source code in the description down below. Please check it out. There's a before folder where you can see the code at the start of the video and an after folder so you can see the code at the end of the video. If you like this video, please give it a thumbs up and also consider subscribing to the channel. So we'll be starting with a single page application built with Angular, Express, Node and MongoDB. If you want to see how we create this application from scratch and step by step, I will link this video in a card at the top right. So we're going to begin adding authentication to our web application with the visual components first. This will include a brand new login page for users that have already signed up to the diary, and also a sign up page which is used to register new users. In the Angular app, I will create these two components from the command line. So I will type ngGC, and that stands for generate component, followed by login to create the login component, and then I'm going to do the exact same with sign-up for the sign up component. Once they've both been created, I will register the login component to the login route and the sign up component to the sign up route in our app routing module. So we will design these two components to contain forms as you might expect to see on any normal website, such as including an email and password to sign up and to log in with. This is going to be pretty basic, but of course feel free to enhance the design to include fields you might like, such as the name, a mobile number and any other details for signing up. And then in the login form, I'm going to copy and paste the diary form HTML. Now, if you want to see how we created this form before, I'll leave a link to that video in the top right now. Now we want to keep this really simple, so reusing this form that we've already built is probably the easiest way. So I'm going to update the fields and labels to username and password, and also the form group name to login form for our login form. I'll also change the submit button to read login, so it's a little bit more clear what it's going to be doing. Now we have a few compile errors, so let's start looking at how we can resolve them. So in the TypeScript file, I will create the onSubmit function and the login form variable as type form group. And then I'm going to initialize this within the ngOnInit function as equal to a new form group, where there will be two keys of username and password, and each of these are going to have their own form control elements. Just as I've done in the diary form component, I will initialize them to an empty string and make them required with the validators.required plugin. I'm going to quickly jump back in the HTML file and update the password input to type password. And the difference this will make is that when you type your password within the text box, it won't be visible in plain text. It will just appear sort of as little dots as you see on any normal website. I'll do this exact same process, but for the sign up component, which is where we're going to be copying the HTML and we're going to be changing the form group, labels, and the submit button to sign up as opposed to login. And then within the TypeScript file for the sign up component, we're also then going to be initializing the form group within the ngOnInit function. So we're going to access these two forms through the header component. I will add a new unordered list that will store buttons to both of these pages. So I will add the class of navbar-nav and then style it so it is floating right. Then I will add two links that navigate to the /login and /signup pages, just as we have registered within the app routing module. And then I'm also going to pass in the text of login and sign up respectively. I will later change these so only one is visible depending on if a user is actually logged in, but we will look at this in a different video. So let's quickly restart our application with ngserve, and if I head to localhost 4200, I can now see these new buttons appear in the top right, and if I select them we can see our forms are now appearing. So we have the login button and the sign up button, just as we expect. And it looks pretty good so far. Now that we have our login and sign up forms created, we can begin to think about how we will store our user data with MongoDB. To begin, we will configure two endpoints in our Express server for both submitting new users to the database and authenticating users when they log in. So these requests to the database will require a new model that we define with Mongoose. So for this, I will create a new user-model.js file. And then within that file, I will require Mongoose and define a new schema called user schema. And I will create this with the mongoose.schema method. I will pass in the username and password as type string. And lastly, I will export this with Mongoose model just as we have done before with a key of user model, and this will then be imported into our Express middleware. So before we begin using the schema, I'm just going to enhance it in a couple ways. So first, I will make the username and password as required fields. So in the schema, I will wrap the type in curly braces and specify the key of type for both, followed by a colon and then string. Then I will append a new key of required with the value of true. Now our schema will throw an error if either field is empty. We also want to ensure that our username is unique. So for this, I will use the Mongoose Unique Validator plugin. So I'm just going to install this with npm install --save mongoose-unique-validator. I will import the validator into the file using the required keyword as we have done before. And then within the user schema, I will make unique as true within the username parameters. We then call the plugin after the schema is defined with user-schema.plugin and then unique validators within brackets. This will ensure our username is unique as we enter it to the database. Now that we have our user model defined and validated, we can make it available within the Express middleware by storing it in a constant and calling require, pointing to the user-model.js file. At the bottom of the file, I'm going to register a new post endpoint for the URI of /signup. And within the signup method body, I will define a new instance of the user model because we will need to then send that to the database. I'll do this with a new constant of user model equals new user model. Then within curly braces, I'll define the key of username, colon, then the request body username. And the same for the password. But if we continue to process the password just like this, we'll be breaching huge data privacy concerns for our users, as we will be persisting their password data in plain text. So instead, what we want to do is hash the password so it cannot be read from the database. We will understand how we use the hash to verify the password in a future video, but to begin hashing, we will install a new package called bcrypt with npm install --save bcrypt. I will then import it to a constant as bcrypt, and then in the signup method, before we define our user model, I will use bcrypt package and call the hash method. The hash method will accept the password as an argument and apply a hash function to it. So for this, I will pass in the request body password as the first argument, and then number 10 as the second argument. The number 10 instructs bcrypt to the degree of complexity to apply the hash function, and then after the hash method, we can chain a promise to the hash value by calling .then, passing in the new hashed password. Let's just call this hash for now, and then creating a new user object with the password as equal to hash, rather than the request body password. So now we're no longer handling that plain text body password. Now I can save the user to the database by calling user.save, and again I would chain a promise with .then, passing the result back to the user with status 201, and a JSON response with a message of user created. I'll finally add a catch block with an error code of 500 to detect any errors in sign-up issues. With our backend set up, let's connect our Angular app with the new endpoint. So first, I'll create a new shared service for authentication that I will use to manage requests to and from our forms. I'll call it auth service, and I'll place it in the shared folder. I'll mark the service with the injectable annotation and provide it in the root so all of our components have access to it. For our sign-up form, I will add a method called signup_user in the authentication service TypeScript file. The signup_user method will accept the username and password that it receives from the sign-up form, and then it will pass these to the Express middleware endpoint. So in order for our signup_user method to make the call, I will make the HTTP client available to the method by injecting it within the constructor as we have done before. So using the HTTP client, I'll submit a post request to the localhost 3000 / and then sign up. I'll enrich the request with an item that holds the user authentication details. So these details will be stored in a new interface. I'll create a new shared file once again called auth-model.ts, and within the file I will export an interface called auth-model. And this auth-model, just for this example, will store 2 strings, and that will be for the username and the password. So if we head back into our auth service, I will create a new instance of our auth model, which will hold our username and password, and which we will then pass into our sign-up endpoint with Express. So I'll write const auth model and then a colon followed by auth model, and that will be equal to the username, which is equal to the username, and the password, which is equal to the password. I'll pass the auth data as the second argument in the post request, and we are passing the password as plain text within the application, but it will be the Express middleware that will perform the hashing on that password before it persists it. So after we send the request, I'll subscribe to the response and log it to the console for us to see. So the pieces to our sign-up form are nearly complete. We have our form, we have the TypeScript method that accepts the form response, we have an auth service that will send the request to the Express middleware, and the Express middleware that will send the request with the hashed password to our MongoDB database. So all that's missing is a connection between the form's TypeScript method and the auth service. So for this, I'll inject the auth service into the signup component through the constructor. Then I will call the signup user method within the onSubmit method. This will pass in the signupform.value.username and the signupform.value.password as arguments, because we're passing in the username and password. And we have a fully connected signup component. So if I restart our backend service and open the application, we can test our signup form. So let's add a username of a@aneesh.co.uk and password of testing, and let's hit sign up. And in the console, we can see the message and the result. So if we expand the result, we can see the username returned and the password appearing as an unreadable and undecipherable hash. This is how our data will be stored in the database. If I try to resubmit our form, in the response we will see an error in the console. And if we expand the error twice, we can see a message telling us that username is expected to be unique, and this is our Mongoose unique validator working for us. So this is really great so far. And just for completeness, let's verify that our newly signed up users are persisted into our MongoDB database. So I will head to mongodb.com and log in. Then within my cluster, I can select collections. And if I expand user models, we can now see the entries that are held within our database. And this will contain the username and password of our signed up users. So this is now a complete sign up solution. Let's just quickly add one more user into our form. I'm now going to refresh the database and we can see that it's been persisted, so we have this hashed password. And that completes this video where we've added a couple forms for signing up users and logging them in. For this application, we will only allow logged in users to add diary entries to our database. And for that access, we will focus on how we can tell the browser that the user is logged in. We achieve exactly this through the use of web tokens. Simply put, the web token is a special string that our backend server will create and pass to the browser when a user logs in. The token will be attached to the current session the user has in the browser. Then, when they interact with the application, we can reference the token where required to validate their request to enable or disable access to specific pages or actions. The first phase of logging in will involve comparing the username and the generated hash of the password from the login form with the details that we've stored in the database. When our user hits the login button, we will want to send a request to an Express endpoint to validate these credentials. I'll begin by defining a new post endpoint with Express as /login. The first objective is to verify that the username entered within the form exists within our database. We can do this by calling the find_one method on the user model. The find_one method will search MongoDB for a particular record, and for our purpose, we will pass in the parameters where the key is username, followed by a colon, and the value is the request body username from our form. This find_one method will return the promise to us, so we can hook a then clause to the search and begin to use the user object that is returned to us by the method. I will name the returned user object from our find_one call as user within the then clause. And before we verify the password, I will add an if statement to check for the user to be present. If they're not, I can return a response with a 401 status, and then I'll be passing in a JSON message of user not found. So now that we know our user does exist, we can verify the user password. Now we cannot see the password itself, but we can compare the hash of the password passed into our form with the hash value stored in the database. This way, nobody can see the password in plain sight. we can use our bcrypt package that we have already installed into our project to perform the comparison. We will do this by using the compare method from the bcrypt package. So this will accept the request body password as the first argument and the hashed password from the database as the second argument. I'll simply pass in user.password for that. I will return this comparison from the user model.findOne method and then chain a new promise from this method below. So just to reiterate, the findOne method will check for the condition to be true as we specify in the JSON body, and will return the first object that matches the condition for the username that we find. This is useful for checking if the username matches any rows in the database. There is an alternative method called .find. However, if we use that method, this will return an empty document to us in the event that the username is not found. So back to our password comparison. The promise will receive the result that will be true or false depending if the passwords match. So if our passwords do match, we can now proceed with creating our web tokens that we assign our user in their browser session. Just before we create and assign these tokens, we will want to check if the result is false, and for that sort of situation, that's where the password isn't going to be matching what we have in the database. So for this, we can return a similar response of 401 status, and then I will pass in a JSON message pointing out that the password is incorrect. I'm just also going to add a catch block for all other errors that we might have with authentication, and I'm going to put this at the bottom of our post request. So I'm just going to have a more generic JSON response here. So if we head back, if the user does exist and the passwords match, we can now begin creating our token. So as I mentioned before, we're going to be using the JSON web token package. This is simply a complex string that will be used to enable access for the user across the application where their authorization is checked. You can find more details about it at jwt.io, and I also encourage you to check out the documentation. It provides some really interesting and useful information when we're playing about with our web tokens. So we will want to import the JSON web token package to help us create and validate our tokens. So we can install the package with npm install -- save JSON web token. And now thinking ahead, when we eventually create our JSON web tokens, we will need to pass in details about the logged in user for the JSON web tokens creation. At the moment, we don't actually have access to the user details within this block of the express endpoint. So I'm going to create a new variable in the endpoint. I'm just going to call this user found. I'm going to define it with the keyword of let. Then I will assign it once we have obtained the user within the then block from our findOne request. So now that we have a user created, I'm just going to store the package for JSON web tokens in a constant called jwt, and then I'm going to define it as require and then JSON web token. Then down when we verify the username and password, I can create a new constant called token. I'll create this with the jwt package and using the sign method. The sign method will take a JSON body argument where I will pass in the username : and then userfound.username and the user ID : userfound_ID. We're passing in the ID as a unique identifier for the user for future purposes. Then after the payload of the user and the ID, we need to pass a unique secret string as a second argument to the sign method. This string is used for creating the hashed token, and it works as a private key that is used for creating a hash that is stored on the server. Finally, we will have a third argument that allows us to define many properties, including the expires in property. This will take a string of 1h, which will tell the token to expire in 1 hour's time. This way the user can log in for a 1 hour session before having to re-log in. Now that we've created our token, we need to return it to the browser where it can be used. I'll return a status code of 200 with a JSON response of token, and then token. Now it can be used in the authentication service from our application. So, in the authentication service, I'll create a new method for logging in. This new method is going to accept the username and password, both of type string. Then I will create an instance of the auth data that consists of the email and password as per the arguments of that method. Then I will submit a HTTP post method to the login URL, and I'm going to be passing in the auth data as an argument. If I now subscribe to the response and log it, we can see what happens if we log in. We will call the login method in the auth service from the login component when we submit the form. So passing in the form, email, and password as arguments. I'm just going to inject the auth service through the constructor of the login component. Then I will call this.authService.loginUser, passing in the login form value, username, and login form value, password. Now we can test the login function. So if we test this with an email that doesn't exist, we will get an unauthorized exception. I'm just going to quickly create a new user with the username of new user and the password of test so that we can now test that we can retrieve a token. If we then authenticate with these exact same credentials, we can see in the console below we have our web token printed. And just for completeness, I will try to log in for the new user with an incorrect password, and then down below we can see the error message of password is incorrect returned to the console. What we would like to do now is pass the token into a variable and to send it through to our application. This way our backend can then obtain this token, it can verify it before processing the user's requests. So we're currently printing the token in the auth service. However, I would like to store it in its own variable so it can be obtained throughout the application. So first I'll define a new private variable called token. It's going to be of type string. And then within the login user method, I will assign this.token as equal to the response.token. So now we're storing it in that variable. So we're currently facing a compile error in the auth service. So I will tell the post request to expect the response with a key of token, which is of type string. And I'm going to do this within angled brackets and curly braces. And if I take a look at the rest.js file, we can see we're passing the token in the JSON response. So that's sort of where we're making that connection. I'll also add a getter for the token within the auth service as it is stored privately, and this will simply return this.token. We will later use the getter whenever we want to verify the authorization details of the user when they make a request. So now that our token is stored, we want to use it to control access to allow or deny requests on the back end. To make our token available to the Express middleware, we will need to enrich our HTTP requests made from Angular's front end to now include that token. So once our requests are enriched with the token data, we can perform checks on the Express routes for a token and to validate the token. We're going to enrich our HTTP requests by creating a new implementation of the HTTP interceptor interface. The interface is used to transform incoming requests, usually by using an RxJS operator, and then passing that request onwards to other interceptors or just to its end destination. So at the moment it goes from start to the end, whereas now this interceptor is going to fit within the middle. And to begin, I will create a new interceptor TypeScript file in the shared folder. And I'm going to export the class of auth interceptor, and that is going to be implementing the HTTP interceptor interface. The class will have to implement the intercept method that will accept two arguments, so it will accept the request of type HTTP request and then next of type HTTP handler. And the next is going to allow us to forward the request journey onwards. So within the method, I'll create a new constant. I'm going to call this token, and that's going to be obtained from the auth service by using the getter. And I will inject the auth service through the constructor and call the getToken method. So if the token is not present, I will simply forward the request using an if statement and returning next.handle, and then the argument we'll pass in will be that original request. However, if the token does exist, I will instead enrich the request. So I will create a new constant, let's call this auth request, which will represent the new request. And this will be a clone of the current request. However, I will pass in a new header to the request as a JSON argument. And I'm going to assign the headers key with request.headers.set and to define a new header for the request. The key will be authorization, and that's going to be using the US spelling with the letter Z, and the value will be auth token, so just what we've defined earlier. And we'll touch on this letter Z a little bit later on and why that's important. Lastly, we then send the enriched request with next.handle, and then within the brackets I'm going to pass in auth request, which is our new enriched version, where our express middleware will now receive it. So yeah, just before we proceed, I'll share one small note on the header name we set. So the term authorization is a standardized request header used in HTTP for storing credentials to authenticate with a server. So it's kind of a standardized approach. This is why we've used the key as specified above. The last part of our interceptor is to ensure it is used for all HTTP requests of our Angular app. So first, I'm just going to mark the class with @injectable decorator to allow it to be provided to other areas of the application. Then I will head to the app.module file to pass this class within the providers block. So our application already has predefined interceptors as default within the application, we just don't see them. But I'm now going to add our auth interceptor on top of all of these. So to do this, I'll open curly braces within the providers block, and I'll be specifying exactly where it's going to be applied. So I'll be providing the HTTP interceptors from the common HTTP library, and I will specify the use class as our auth interceptor. So what the application is going to do now is actually override all the interceptors we currently use by default with our new interceptor. But to avoid doing this and to only use our interceptor on top, I'll specify a third argument, which is multi, and I'm going to set this as true. So now our auth interceptor will be used alongside all default interceptors for our HTTP requests. And as we have enriched our HTTP requests with the new authorization header, I will also need to update the rest.js file to accept authorization headers within the cause policy to ensure we don't see a cause failure. So if you're actually unfamiliar with cause, I'll add the link to my video on where we added cause to the application, and I'll do that in the top right. Okay, so the final piece of the puzzle is to now use our token in the middleware to obtain and verify the validity of the token in the request and to grant access to the endpoint if they're satisfied. So in our post endpoint for adding diary entries, I will add a middleware check before the endpoint is executed to verify that token. So first I'm going to add a new ES6 function, and this is going to accept the request, the response, and the next arguments. And I will first obtain the token with request headers and then authorization with the Z, and that's going to come exactly from our auth interceptor whenever we have a valid token. So we can verify the token with the JWT package that we use, and that's going to use the verify method. And what we're going to be doing here is passing in the token and the secret string that we use as the private key. So that will be secret underscore string, as we've taken from elsewhere in our middleware. And JWT will use the token and the string to verify that the token was created by our application and on our server, and that it is not expired. So that's what this verify method is going to do. And if it does not fail, we can then call next. However, if it does fail, I'm just going to add a catch block and return a 401 status with the error message of error with authentication token. That now completes our token verification for the front end and the back end. We can now test this in our application. So first I'm just going to log in. We can't see anything in the browser console. However, if I now go to create a test diary entry, we can see it. I'll quickly restart our application and to remove the token from our browser. And if I now try to add any diary entries, we will now see that 401 error and the entry is not being added. So if we take a look at our application, we currently have a few issues. So for example, the login and sign up buttons remain in the view even though a user might be logged in. There also isn't a logout button, and also the actions to add a new entry appear available even when a user isn't logged in, and this is something that they actually wouldn't be able to do. So the first update we make will be in the header, where we only want to show the login and sign up button if a user is not logged in, and we will want to see the logout button if they are logged in. I'll begin by adding a new list item in the angled brackets of li to our unordered list in the header component, and we'll add the text of logout within it. We'll want to show these list items depending on if the user is logged in or not. And the status of a user being logged in will be a subscription, so we will need to create a subject that emits this data from the auth service. So if I head to the auth service, I'm going to create a new subject, and then within angled brackets I'm going to put boolean, and this listener will be updated to true when the user logs in. I'll add a getter for this listener for the other components to subscribe to as get authenticated listener, and this is then going to return as observable. So now we can subscribe to this subject from other components to understand if a user is logged in or not. Then in the login function within the auth service, I'll open a new if block to check that the token exists, and I'm going to call this .authenticatedSub.next, and I'm going to pass in the value of true, and this is going to emit the value for the subject. If you like further details on subjects, I'll add the card to my video where we cover subjects a little bit more in the top right. We now want the header component to receive that subscription, so I will first inject the auth service through the constructor. I'll create the subscription and call it authentication sub, and initialize it within the ng-on-init function. And I'll be doing this by obtaining the auth service and subscribing to it. I'll also create a boolean in the component as user authenticated, and this is going to be equal to false. Then we can take the value emitted from the listener and assign it to the boolean within the subscribe function. I'll also implement the onDestroy lifecycle hook within the component, and then within onDestroy I'm going to use it to unsubscribe from the subscription. So now that we have access to the status of a user being authenticated or not, I can update each of the list items in our header to be shown with the structural directive of ngIf. So for a new entry and the logout buttons, I'll want to show only if the user is authenticated. So if they're logged in, then they can see the new entry, and they can log out. And the sign up and login buttons only if the user is not authenticated. So let's take a look at what this looks like in our application. And we can see that the data entry button is not visible and that we can only see login or sign up. And then if we log in, we can now see the data entry button is appearing and the logout button is also appearing. So we've made some really good progress so far for ensuring the header correctly shows for authenticated users only. Let's quickly make an update to the actions on the diary entries so only authenticated users can update or delete these entries. So in a similar way that I've done before for the header component, I'll create a new subscription and a boolean within the diary component. Here I'm going to subscribe to the auth service authentication subscription within the ng-on-init function. So I'm going to have to inject that auth service into the component. And then within the subscription, I'm going to update the isAuthenticated boolean. And then I'm also going to unsubscribe from that subscription when the component is destroyed. So in the diary component HTML, I'll then update the table header for actions to only show if the user is authenticated. And I'm going to do the exact same for the table data entry for those actions. Now if I reload our application, we can see the actions are not available if the user is not logged in. And now I'm just going to quickly log in and head back to the diary entries. And actually we can still see the actions are still not available. Okay, so the reason for this is that the subscription for the diary entries is created when we load the component. So when we select diary entries, when we select the home button. And the flow of actions we make are to authenticate. So that will emit the new isAuthenticated data to be true to all the components. However, when we then select home, we're reloading this diary component. So the subscription is then created and the true value that has been emitted from our auth service is not going to be received. So it's still going to be received as false. A simple solution here is to add a new boolean to the auth service, and I can just call this isAuthenticated. And I'll also add the getter for this. And then I will set this to true when the user logs in and the token is present. And lastly, within the diary component, I will also set the isAuthenticated boolean as equal to the isAuthenticated value from the auth service. I'll leave our subscription in place as we will later need it to reflect the login component when we log out. And I'm just going to quickly test this in the application. So if I just log in one more time and head back to the home, we can now see it working as expected. And that's because when we load this diary component, it's now going to be checking the isAuthenticated boolean within the auth service, which is now set as true. I'm going to quickly add some further cleaning up to the user experience to redirect users after they log into the home page. So I'll need access to the HTTP router in the auth service, and I'm just going to inject this within the constructor. And then within the login function, after a valid token has been received, I will navigate to the home page with this.router.navigate, and then within squared brackets I will put / within quotes. So now we can quickly test this is working. So I'm just going to quickly log in, and when I select login, we're taken back to the home page. So far we've been able to prevent the visible components of diary entry and editing entries when a user is not authenticated. However, we are still able to manually enter that URL and access the pages even if we're not authenticated. So if I head into the application and enter / data-entry, we can still see the entry form even though we're not authenticated. And it's true, we won't be able to actually submit this because the token will be validated upon submission, but still we don't want the user to be able to access this page. So we're going to add some route redirection for if this were to happen, back to say the login page, and we're going to do this through route guarding. So route guards are used to ensure only traffic we permit is enabled for specific routes. So for this, I will create a new file within the shared folder and going to call this route-guards.ts. And in a similar style to adding the interceptor in my previous video, Angular provides us with an interface to implement and a method to override that we can then inject into our application to perform every time a user attempts to access a route. So we're going to implement the canActivate interface, and this interface will require us to implement the canActivate method that accepts two arguments. So first we're going to have the activated route snapshot of where we're trying to access, and the router state snapshot of all available routes in the application. And this method will return a boolean or an observable or promise that contains a boolean, and this essentially will determine whether that route can be accessed or not. So within this method, we want to check if the user is authenticated, and if they are, then we can return true. However, if we're not, we're simply just going to redirect them back to that login page. What I'll then do is provide this route guard to the specific routes in our app routing module for the authentication check to take place. So first, let's inject the auth service into our route guard class. I'll mark the class with the @injectable annotation to ensure it can inject other services into it. And then within our canActivate method, I will obtain the boolean if the user is authenticated with the getAuthenticated method. Next, I'll check if the user is not authenticated with an if block. I'll navigate them back to the login page with the router. So again, I'm just going to inject that router through the constructor, and then I will call this .router.navigate, passing in the login page. Lastly, I'll return the isAuth boolean, which will be true in this case, to enable the user to access the page. The final step in applying the route guard is to specify which routes will use it. So if I head into the app routing module, I can inject the route guard within the decorator. So just under exports, I'll add a new key of providers, and then within squared brackets, I'll pass in the route guard. Each route that we specify within our routing module can accept an array of guards after the property of canActivate. So for the data-entry and the edit routes, I'll add a new argument after the component called canActivate, and I'll pass in an array with just the route guard specified within it. Now if I reload the app and try to manually navigate to /data-entry, we can see that we're automatically taken to the login page. This is great.
So far our application allows us to log in and sign up. However, the logout button doesn't actually have any functionality. We can kind of effectively log out just by refreshing the page, but this is actually a bug, and we're also going to fix this later in this video. So to provide the logging out functionality, I'll first head to our header HTML file and change the logout button from a list item and into a button. I prefer this way as the button represents an action rather than a destination as the other header items do. I'll also add some styling to make the margin top 10 pixels, and this will align our button with the other items in our header. So next I will add a click listener to a method, and we're just going to call this logout. And then if I head to the header TypeScript file, I'll pass on the logout call to a new logout method of the auth service, which we also need to create. So we're passing a call through to the auth service as it is central to all of our authentication actions, and this will enable us to perform 4 key functions for logging out a user in one go. So first we need to reset the token to an empty string. We need to mark the isAuthenticated boolean to false. We need to emit a new false update on the authentication subject to all listening components. And lastly, we want to navigate the user back to the home page. If you want to see the video on where we've created these 4 components for logging in, I'll leave the card to that video in the top right. And now we can check this out in the application. So I'm just going to log in with the username and password. And we can see the header has changed and the edit/delete buttons appear on our home page. Now if I select Logout, actually we don't see any change. So the reason we're not seeing a change is because this diary component does not actually use the subject for updating whether a user is logged in or not. So it's not actually receiving that false message that is being broadcasted. So in my previous video, we did not use the authenticated subscription in the diary component. Instead, we only find out if a user is authenticated through the isAuthenticated boolean. And as the diary component does not actually reload, the isAuthenticated boolean is not reset in the ngOnInit function. Therefore, we simply just need to add that subscription by setting isAuthenticated as equal to the status, and then we will achieve that desired behavior. So now if I log back in with the username and password, we can see the buttons appear on the home page, and if I log out, that subscription is now going to be received by our diary component. It's now going to update the isAuthenticated boolean to false, and we can now see that they have disappeared. Okay, so our logout function works pretty well so far. However, it's a little bit more complicated than that. If you remember from my previous video, we also added an expiration to our token to ensure that the user is logged out automatically after 1 hour. What we would like to do is to trigger the logout function after that 1 hour has elapsed after the user has logged in. And luckily, there are some built-in handy functions for us to do this. So first I'm just going to head to that rest.js file, and I'm going to enrich the response from the login function to pass a new parameter of expires_in with the value of 3600. And this is going to represent the number of seconds in 1 hour. Our Angular app can then handle this value appropriately, and back in the auth service we will update the generic type to receive the new expires_in property of type number. And then after we've confirmed that the token exists, we can use the setTimeout method to call an ES6 function after a number of milliseconds has passed. So for this, I'll pass in a call to the logout function, and this is going to be called when the number of milliseconds has passed, and for the number of milliseconds, I'm just going to pass in the response.expires_in value, and then I'm going to multiply that by 1000 to convert it from seconds to milliseconds. If I were to log out manually, we would also want to clear this timer. So I'll create a new variable for the auth service, and I'm going to call this logout timer. And then it's going to be of type any. And within the login method, I'm going to assign this to the setTimeout method. And then within the logout function, we're able to use the clearTimeout method that is also built in and available with Angular. And I'm going to pass in our logout timer as the argument. So what this will do is clear our timer every time that we manually time out, but whenever we do log in, that elapsed time is going to begin. So to quickly show this working, I'm actually going to remove this 1000 multiplier. This way it's going to log us out after 3.6 seconds. And then if I head back into the application and I log in, we can now see that we've automatically been logged out, and we can see at the top right that the login buttons are now available. So the second part of this video will fix the bug that we saw at the start, where our user is logged in and when they refresh the page, they're then logged out. So we currently store the token within the token string of the auth service. Therefore, when we refresh our page, the component is destroyed and the token is emptied. So we see our user is logged out. We'll resolve this by storing our token in the local storage of the browser. So the browser's local storage provides a storage system that allows key value pairs to be stored in that web browser and without an expiration date. Therefore, when the browser window is closed, the local storage will be persisted in the browser. I'll leave a link to local storage documentation in the description for you to check out. We can begin by creating a new method that will store our data into the local storage. We will want to store the token and the expiration time to ensure the user stays logged in if they're within that 1 hour time frame. and have not clicked Logout. I'll create a method, store login details, that accepts the token of type string and the expiration date property of type date. So we're not passing in the expires in value itself, rather the exact time the token will be expiring. Then when we relaunch our application within the browser, we can recalculate the remaining seconds of the session before we then call that logout function automatically. We can store our values in the local storage using the built-in local storage API and calling the setItem method. This will accept a key and value that will be persisted into the browser. So I'll do this once for token and passing in the token, and then again for the expires in property, passing in the value as type isostring. And the isostring is a serialized version of our date. So we're going to use this method to persist to the local storage after we log in and the token has been created along with the expiration date. So the expiration date can be obtained by creating a new date object which will contain the current date and time. Then we can create a new constant of the expires date and passing in the current date with the getTime method and adding the number of milliseconds on as the expires in value multiplied by 1000. We can then pass this .token and the expires date into the store login details method to persist the values into local storage. I'll create an inverse method to remove these, and I'm just going to call this method clear login details. And this method will use the built-in remove item from the local storage API, passing in the key of token and also the key of expires in. And this method is going to be called whenever we log out. So if I open the application, we can now test our local storage by opening up the developer console and navigating to the local storage tab. And this will show us the token and expires in properties updated as we log in and then also updated as we log out. Our local storage now contains the data we store upon the authentication and we'll remove it once we log out. The very final part to using local storage is to automatically authenticate our user when we load the page if the token is available and if it is not expired. So from a high level, whenever our application is loaded, we'll want to check if the local storage contains a token that is not expired. Then we want to automatically assign them values within our application if they're available. So I'm going to create a new method called getLocalStorageData, and this is going to return a JSON object of our token and the expires in value. This method will be called whenever the app.component file is created, so whenever our application is loaded. And then within this method, I'll obtain the token with localstorage.getItem, passing in token for the token, and expires in for the expires in property. If either of these are empty, I'll send an empty response back from this method. I can check whether either of these are empty with an if statement, where we're saying if the token or the expires in value are empty. If, however, both are present, I want to return a JSON response with the token and the expires in as a new date object. So I'm just going to create this by passing in new date and then the expires in date as an argument. The getLocalStorageData method is going to be used by a slightly higher level method that is going to be taking that data and assigning it within our application. So I'm going to call this method authenticate from local storage. So within authenticate from local storage, I'll first obtain the local storage data as we've just defined into a constant called local storage data. We now need to verify that the token has not expired, and if it hasn't, then we can update the token and the expires in properties of our application. So first let's check that the expiration date is not invalid and is therefore in the future. I'll create a new constant called now with new date and create a new constant called the expires in date, which is calculated by the local storage data expiration date.getTime value minus the now.getTime value. So now.getTime will provide an integer, which is the number of milliseconds the current present moment is from January 1st, 1970, and the expiration.getTime does the exact same thing. However, that will be from January 1st, 1970, all the way up to the expiration date. So if the expiration date is greater than now, we would expect this value to be positive. I'll create a new if block where expires in is positive, where we can set this .token as equal to the local storage data.token. We will also want to set is authenticated to true and also broadcast a true boolean in the authenticated subscription. Lastly, I'll also update the logout timer within the set timer method, passing in the value of the expires in value, but then we want to divide that by 1000 to convert it from milliseconds to seconds. So now that our auth service is updated, and just before we start our application, I'm going to make one small change to our header component TS file. So in the ng-on-init function, you can see our subscription to the authenticated sub in the auth service, which will then set the user authenticated value as equal to the status. The problem we have is that when we restart our application, the app component will be loaded first, and that will be sending out this user authenticated sub message. However, the header component might not always be loaded. So what I'm going to do is also set the user authenticated value as equal to the auth service get is authenticated boolean. And this way we're not just relying on the subscription to tell us whether the user is logged in or not, and when we load the header component, it will also take it from the boolean of is authenticated from our auth service. We'll run our authenticate from local storage method when the application starts by implementing the onInit lifecycle hook in the app.component file, and then I'm going to inject the auth service into a constructor, and then I'm going to call the authenticate from local storage method. Now if I restart our application and log in, we can close the window and we can reopen the window, and we can see that the page is still logged in and that the local storage contains our token and expiration. So that concludes this video on how we can persist user details within the browser, how we can create a logout functionality that it also expires after a specified time within the code. And it also concludes the tutorial on how you can create and use authentication with MongoDB. So thank you so much for watching this video, and as always, please leave a comment down below if you have any questions, and subscribe to the channel if you'd like to see more.